My name is Amanda Rudolph, and I will be talking to you today about weathering in Diagenesis in the Glen Torridon region of Gale crater Mars, using visible to near infrared spectral data from the Curiosity rover. Glen Torridon is a unique region in Gale crater, both compositionally and morphologically. This can be shown through strong orbital detections of iron and magnesium smectites, shown here on the left in dark purple, as well as its recessive trough morphology that you can see here in the simplified cross-section on the right. It is sandwiched between two erosionally resistant units, the VNIR ridge and the green cube pediment. Within Glen Torridon, there are three stratigraphic units defined by their orbital and in situ morphology. Starting from lowest to highest elevation, there's the Glen Torridon Jura, which is comprised of laminated mudstones with a minor sandstone component. Knockfarrell Hill, which is comprised of interstratified mudstones and sandstones, and Glasgow, which is defined by its light-toned and fractured appearance. Their approximate boundaries are shown from the bird's-eye view high-res image on the left, and then on the right, these are mass-cam mosaic images of the type bedrock of each of these units. My primary research question is looking at the distribution of minerals observed in Glen Torridon and what they tell us about the diagenetic history of the sediments. I've tested three hypotheses, the first being that clay minerals are authigenic and formed through surface weathering. And to test that, I'll be looking at the distribution of clay minerals. They would be ubiquitous throughout Glen Torridon in this scenario. Hypothesis 2 is that the clay minerals are detrital, and in this case, the distribution of clay minerals would be correlated with depositional facies. And lastly, the early clay mineral deposits will have affected the flow of diagenic fluids, and this can be tested if there is limited diagenesis in clay-rich rocks. We already know the mineralogy at drill site locations through the X-ray diffraction instrument ChemMin on board MSL. This figure at the bottom shows the hematite in red and phyllosilicate in green abundance from ChemMin data from the VNIR ridge Jura through Glen Torridon. And you can see some trends starting to appear. Overall, you get an increase in clay abundance in Glen Torridon until we reach the Glasgow unit. And then this opposite trend rings true, where you get this decrease in hematite throughout the Glen Torridon unit that increases slightly within the Glasgow unit. In particular, iron-bearing clay minerals may be detectable using VNIR imagery onboard Curiosity with both the MassCam multispectral images and ChemCam hyperspectral passive data. On the right, in these spectral plots, we have on the x-axis wavelength the full range in the MassCam wavelength range, and within the blue box is the ChemCam wavelength range. And then for the y-axis, this is relative reflectance, and these are all shifted and stacked for clarity. The main features that we're looking for with smectites are a 650 nanometer band absorption and or a 910 to 970 nanometer absorption. MassCam filters sometimes can obscure the 650 nanometer band, but the band should be detectable by the ChemCam hyperspectral data, and MassCam should be able to detect the 910 nanometer band if other ferric minerals like hematite are absent or have low abundance. These spectral properties were used to detect and map the distribution of clay minerals in Glen Torridon. ChemCam has detected the 650 nanometer absorption that's consistent with iron magnesium smectites, both within the Glen Torridon Jura and in more recent terrains moving away from the green cube pediment. This plot here has sols or Martian days on the x-axis and the 650 nanometer band depth on the y-axis. And you can see an increase in this band depth in the Glen Torridon Jura, a decrease through the Knockfarrell Hill member and entering into Glasgow member, and another increase in the 650 meter band depth as Curiosity has moved away from the green cube pediment contact with Glen Torridon. Glen Torridon exhibits significant variability in VNIR spectra and which can be indicated by the color of bedrock and drill tailings. So all of these images are approximate true color MassCam images of the drill sites within Glen Torridon. In the Glen Torridon Jura and Knockfarrell Hill, we often see specular purple tan bedrock that have more reddened tailings. that transitions to sometimes specular gray bedrock with blue or gray tailings in the Glasgow member. This can be shown quantitatively with the red to blue ratio. There is an overall decreased reddening with elevation in Glen Torridon that could be caused by the recrystallization of fine-grained red hematite to coarse-grained gray hematite during diagenesis. This trend is less prominent in DRT spots. DRT spots are regions where the rover has used its dust removal tool to remove dust from the bedrock. This decreased reddening with elevation trend is abundantly clear when looking at drill tailings. 5 spectral classes with different mineralogical and diagenetic implications are observed in Glen Torridon, all defined off of mass-cam spectra. This plot on the left has the mass-cam wavelength range on the x-axis and relative reflectance that's stacked on the y-axis. These are actual mass-cam spectra that I've pulled. And on the right, these are representative lab spectra that have been convolved to mass-cam filters to show examples of the type minerals that we would expect with the features observed. So in class 1, in purple, this class is consistent with iron magnesium spectites with an absorption and longer wavelengths of greater than 900 nanometers. Class 2 is consistent with fine-grained red crystalline hematite, and we see this in small amounts, maybe less than 2 to 3 weight percent, with a weak absorption band at 867 nanometers. Class 3 is consistent with a variety of minerals, some of which include iron 2+, 3+ smectites, microplated hematite, goethite, and lepidocrasite. While this class is not diagnostic of a particular mineral, it does have a unique spectral feature, which is an absorption around 700 nanometers. Class 4 is consistent with a general lack of iron minerals and or very spectrally flat iron-bearing minerals, some of which could include coarse-grained hematite or magnetite. This class is defined by the ratio of the 805 and 640 nanometer multispectral bands being approximately 1 or less than 1, so you get this general downwards trend in your spectrum. Class 5 is consistent with a lack of fine-grained red hematite, and is defined by the 640 to 527 nanometer ratio, essentially your red to blue ratio. And in this class, the ratio has decreased, so we get this decreased reddening, flatter spectrum. So within Glen Torridon, the Glen Torridon Jura and Knockfarrell Hill exhibit spectral characteristics that are consistent with widespread smectites and weak patchy hematite signatures. On the left is the mass-cam multispectral data showing some examples of the different spectral classes observed within these units. On the x-axis is wavelength again with relative reflectance on the y-axis. And you can see spectral classes 1, 2, and 3 are observed. And then on the right, we have some ChemCam hyperspectral data of the drill tailings within these members. And you can see this flattening that we've talked about at approximately 650 nanometers. While it's not a full absorption, a flattening is still indicative of potentially iron magnesium spectites. The Glasgow member has a lighter tone, more fractures, and exhibits diverse spectra closer to the green hue pediment. So the spectral classes that we see within Glasgow, we see them all, but their distribution is varied. So spectral class 1 is observed only away from the contact of the green hue pediment. Spectral classes 2 and 3 are observed pretty much everywhere, and spectral classes 4 and 5 are observed only near the contact with the green hue pediment. And looking at the ChemCam data of tailings on the right, you see a potential flattening at 650 nanometers, but also an overall spectral flattening, which is more consistent with classes 4, classes 5. And both of these drill sites are relatively close to the contact between the Glasgow unit and the green hue pediment unconformity. We used a linear fit on mass-cam spectra in the longer wavelength ranges to get more specific band center values, showing band center on the x-axis ranging from 850 nanometers to 950 nanometers versus elevation on the y-axis and color-coded with the different units. And you can see where different spectra are observed within both the hematite band center range and the iron magnesium spectite range. Now, the distribution of these spectral classes are an important aspect of this work. So on the left here, we have this bird's eye view of the traverse, where each of the colored dots represent a spectral class, consistent with the colors from the plots we've observed previously. And I'll be highlighting the trends that I've already touched on, but I'm just another visual representation of them. So class 1 in purple, it's not detected near the unconformity, but it is everywhere else. Class 2 is found everywhere, but has weak spectral signatures. Class 3 is almost everywhere and actually tracks hematite rather than the iron magnesium spectites that we had originally thought. And classes 4 and 5 are associated with the green hue pediment unconformity, which is down in the bottom left of this image. On the right, in the simplified strat column, going from the VRR up through to the green hue pediment, each of these circles yet again represent a spectral class, and the size of the circles represent the relative abundance. You can see there's more clays in the lower stratigraphic units and less in Glasgow, and Glasgow has 2 rows of dots to represent its general composition away from the green hue pediment unconformity contact, and then on the bottom of this Glasgow image, and then on the top represents the composition that we see near the contact between Glasgow and the green hue pediment unconformity. Similar but stronger clay-like spectral signatures have been observed in Sutton Island, previously traversed by Curiosity, in association with evidence for subaerial exposure. So this plot on the left is from mass cam spectra that's consistent with smectites in Sutton Island. So you're looking for that 900 nanometer or longer absorption, which we see. And evidence for subaerial exposure includes these mud cracks that you can see on the right. And Glen Torridon exhibits weak smectite signatures relative to Sutton Island, possibly due to less extensive weathering within Glen Torridon. The abundant clay minerals in Glen Torridon may have acted as an impermeable region, leading to a lack of notable diagenesis within Glen Torridon while being surrounded by bleached units both in the Glasgow member and the Vera Rubin Ridge, where bleaching is an indicator of late diagenesis. So here on the top we can see this is the Vera Rubin Ridge mass cam mosaic, and on the bottom is a mosaic of the Glasgow member at that contact between the Glasgow member and the green hue pediment unconformity, and you can see bleaching in both of these images. We propose the presence of the green hue pediment during later diagenesis directly affected the mineralogy observed. So we've created a very simplified model using topographic data from Vera Rubin Ridge up through to the green hue pediment. The x-axis for each of these panels is the distance of this cross-section in meters, and the y-axis is the elevation. For regions that have the purple backdrop with the red dots, that's clay dominant with minor hematite, and with its the red backdrop with purple dots, that represents hematite dominant with minor clay components. Starting in the top left, you have the original deposition of sediments in panel 2 on the top right. Erosion occurred to create Mount Sharp, so we get this near modern topography. Panel 3 on the bottom left, there's the deposition of the Sticker Point Group aeolian cap, and diagenetic fluid alters sediments beneath the cap. The clay dominant units, in purple, focused diagenetic fluids and alteration to margins of clay-rich units, so in the Vera Rubin Ridge and at the top of Glen Torridon. And in panel 4 on the bottom right, we have erosion to the modern topography, leaving behind the green hue pediment and these bleach zones that we see in VRR and in the Glasgow member. So some general takeaways that I hope you get from this talk are that smectite and hematite spectral signatures are ubiquitous throughout all depositional and morphological phases in Glen Torridon, suggesting an origin through early surface weathering and oxidation. Late diagenesis appears to have been very limited within Glen Torridon itself. The presence of impermeable phyllosilicates focused diagenetic fluids and alteration to margins of phyllosilicate-rich units, in other words, to Vera Rubin Ridge and to the top of Glen Torridon, and that a lack of clay mineral signatures near the green hue pediment unconformity suggests destruction of clays during late diagenesis. So the diagenesis was focused along the green hue pediment base, and diagenetic fluids were trapped between the capping unit above and the phyllosilicate-rich units below and led to enhanced alteration in that region. I'd like to thank you for taking the time to listen to my talk, and if you have any questions or comments, I would love to hear them, so please feel free to reach out via email or any other means.